Alright guys, in this video we're going to continue talking about linear functions and some of the stuff that we can do with those linear functions. First thing we want to start off with is something, hopefully a problem that looks a little familiar to you. So a store starts the day with 200 t-shirts, sells an average of 15 shirts per hour. We want to write a function that represents the number of shirts. So let's go ahead and check this out. If we write this function, we want to figure out what are we starting with, and then at what rate does it increase or decrease. So the starting point here is going to be our 200 shirts. So first of all, f of x, or y if you want to call it y, but let's stick with the f of x notation, the function notation. So our function, or the number of shirts, on hand, that's what this function is going to represent, is equal to, and remember we have a starting point and a rate at which we increase or decrease. So our starting point is 200 shirts, and the rate at which we increase or decrease, well, if we have 200 and we sell 15 per hour, then we're going to subtract 15 for every 1 hour, and if x equals the number of hours, that's our function. So this function is going to tell us how many shirts that we have for any given hour. We can plug in 3 hours in here and figure out how many shirts, or 15 hours and figure out how many shirts, and so on. So there's our function. So it looks like this: f of x equals 200 minus 15x, where x is the number of hours. So what we want to do is we want to, just a refresher hopefully, we want to look at what the graph of this thing looks like. So remember, this is our starting point, or if you remember, we have this form or notation, the y equals mx plus b. This is called slope-intercept form, and it's called slope-intercept form because we can take two pieces of information from it. Whatever number is by itself is the y-intercept. Okay, so for our particular purposes here, the number that's by itself, or the constant in this particular case, is 200. That's the y-intercept. So if I'm going to graph this, that's kind of like my starting point. I go up to the 200 and I plot my point, and there's my y-intercept. The other number that we can take from the slope-intercept form is obviously the slope, using that given name. So the coefficient, or the number in front of the x term, is going to give us our slope. So you got to be careful and make sure you're paying attention, not just to the order, but what number is in front of x. And in this particular case, carry the sign with it, we've got a negative 15. So that means that we go to our 200, we go down 15, our slope here is negative 15, or if you want to write it as negative 15 over 1, that's probably a bit helpful. So we would go down 15, which looks like it's about right around here, and then over 1. Down 15, over 1, down 15, over 1, and so on, and we would get a graph that looks like this. Okay, so in this video we want to focus on, there are really 2 points of interest if you look at this graph that we want to focus on. The first point is this one. This is called the y-intercept, and if we wrote the coordinates of the y-intercept, remember coordinates are always x, y. They're always written x, comma, y. So this tells us how far in the x, and this tells us how far in the y. So this point right here, this happens to be our y-intercept that we took from the slope-intercept form. This point would be written as 0 in the x because we didn't move off of that y-axis. We didn't move left or right. So 0, comma, and then we had to go up 200. So that would be 0, comma, 200. This would be the y-intercept. The other point that we're interested in is not the one that I have marked here. It's this one down here. And this particular point is where it crosses the x-axis. So this is called the x-intercept. And the way that I find that, again, I'm going to figure out how far I move in the x direction. Well, we don't know how far we move in the x direction. We do know how far we've moved in the y direction, and we haven't moved at all in the y direction. And so we haven't gone up and down, so the y coordinate for my y-intercept is 0. And if I want to figure out my x coordinate for that particular point, that x-intercept, in this case, I can actually take my 0 and plug it in. Remember, this is the same as y equals 200 minus 15x. So I can take this 0 because I know it's sitting on that axis and we haven't gone up and down. I can take this 0 and I can plug it in for y. And this is a really simple one to solve for. So 0 equals 200 minus 15x. I can move this over to make that positive. That's 15x equals 200. And solve for x, a little quick math. 200 divided by 15 is going to give me 13.33 repeating. So my coordinate here, when y is 0, my coordinate would be 13.33 repeating. So just looking at the context here, the reason that these are points of interest, if you look at the context and take the context into account, my x variable is hours in this case. It's hours, okay? So if this is the number of hours, this basically means if no time has passed, I start with 200 t-shirts. So we kind of know that already, that the y-intercept is kind of the starting point, and it's the starting point because in this particular case, no time has passed. So because my hours is 0, this is the starting number of t-shirts that I have. Well, how about down here? What's 0 down here within the context of the problem? Well, the 0 down here is actually the number of shirts that I have. So this x-intercept actually tells me how many hours pass before I run out of shirts. So that's why that x-intercept can tell us a lot of information, because whatever we're measuring, in this case it's shirts, it might be money, whatever it is, it tells us when we have nothing of that particular thing. And so that's why the x-intercept can be useful. So we're going to go through this process. Here's the definition of an x-intercept. It's a location. It's a location, so it's a coordinate. It should be always written as an xy coordinate. Well, if we look at these three, I just kind of drew some dummy lines over here, these three. Here's a y-intercept. Here's a y-intercept. Here's a y-intercept. What about the x-intercept? So here's one x-intercept. And if we notice, we don't know how far over we are in the x direction, but again, we've got a 0 for our y. And that's because I haven't moved up and down. So we don't know what the x is, but the y is definitely 0 because I haven't moved up and down from that axis. We move over to the blue line. The blue line, the x-intercept looks to be right here. And again, we don't know what the x is. We don't know how far over we are. But we know that we haven't gone up and down. We're sitting right on that x-axis, and so the y coordinate is going to be 0. And this is going to play into how we find these things. If you look at the green line, just real quick, I wanted to show you an example. You don't necessarily always have to have intercepts. This green line goes straight across. It's perfectly horizontal. And in this case, unless it was sitting on the axis, you won't have an x-intercept. So there are some particular cases where that's not going to get zeroed out. Okay? So looking at the y, and I'll do this very quickly again. Here are the y-intercepts. Here's my first y-intercept. Now again, we don't know how high up we are. We don't know the height of this thing. But what we do know is that we haven't moved left and right. And what that means is for my x coordinate of this particular point, it's going to be 0 comma something. Moving on to the green one. The green one is perfectly horizontal, but it does cross that y-axis, so it didn't have an x-intercept, but it does have a y-intercept. We don't know how tall it is, so whatever that y-intercept is, whatever that y-coordinate is, we don't know, but we do know that the x-coordinate is going to be 0 because we haven't moved left and right. And same thing for the blue one. Any y-intercept is going to sit right on this axis, and so we don't know how far down we are. We know it's going to be negative, but that x-coordinate is going to be 0. So 0 comma something. And you notice all of these, anytime you have a y-intercept, you're going to have a 0 for the x value. All right, so just a couple quick examples, and we're using the fact that back here, when we looked at our x-intercepts, remember, the y was always 0. So if I want to find the x-intercept, I can use the fact that the y is always 0. If I want to find the y-intercept, I can use the fact that the x is always 0. So let's use that and go ahead and find the x and y-intercepts in a couple examples. So first thing, the x-intercept. The x-intercept is where it crosses the x-axis. What I want to do is I want to plug in y, or plug in 0 for y. So wherever I see a y up here, I'm going to plug it in. So 0 equals 3x minus 1. And this, when I go through and solve it, it's going to tell me where this intercept is. So in this particular case, I can add 1 to both sides. So 1 equals 3x. Divide by 3, divide by 3. So I know that 1/3 is going to be my x coordinate. And what's my y coordinate? Well, it's 0. We plugged in 0 for y. We know this is an x-intercept. So I've got a point at 1/3, comma 0. So let's go ahead and plot that point. So I go over, let's call this one here, 1/3, maybe, I don't know, right around here, we'll call it. So there's my x-intercept of my function, and it's at 1/3, comma 0. All right, let's go do the y-intercept real quick. And again, if you look back to what we did before, any y-intercept is going to have an x coordinate of 0. So that's what we do. We say it's a y-intercept. I'm just going to plug in 0 for x, wherever I see an x in this original. So let's go ahead and do that. I've got y equals 3 times 0 minus 1, and y equals -1. So my y-intercept, again, it's always a coordinate. We know the x is 0, the y is going to be -1. So let's go ahead and plot that. -1's about right here on my axis. There's my y-intercept, and we can draw our line, sketch our line that goes through those points. You want to make sure you label your intercepts when you're going through and plotting these and graphing these too. So this is 0, comma -1, and we've plotted it using the x and y intercepts. All right, a couple more quick examples here, and this is in a different form. So this form is what we call standard form, and you don't need to know the name of it, you just need to know the process here. And again, we're going to try to find the x and y intercepts, so let's go ahead and get started. It doesn't matter what form that thing is in. If I'm finding an x-intercept, I'm plugging in 0 for y. So let's go ahead and do that. Anywhere I see a y, I'm going to plug in a 0. So I've got 3x plus 5 times 0 equals 15. Well, 5 times 0, that pretty much just cancels that out. I'm left with 3x equals 15. So I know that my x-intercept is going to have an x-coordinate of 5. And in particular, the y-coordinate I know is going to be 0, so x-intercept is 5, 0. Let's go ahead and find the y-intercept. The y-intercept, I'm going to plug in 0 for x, because I know it's not going to go anywhere up and down. So when I plug in 0 for x, I'm going to be left with 3 times 0 plus 5y equals 15. This is gone because 3 times 0 is 0, and then divide by 5 and divide by 5, and my y is equal to 3. So I've got 0, comma 3 as my y-intercept. So 0, 3 looks something like this. There's 0, 3. 5, 0, my x-intercept. 1, 2, 3, 4, 5. Looks something like that. So I've got my line plotted